Let us understand the concept of an independent voltage source in a detailed and simple way. In electrical circuits, a voltage source is a device that provides electrical energy by maintaining a certain voltage difference between its terminals. When we say the source is independent, we mean that its voltage does not depend on any other voltage or current source in the circuit. That is, the voltage it provides remains the same no matter what else is connected to it. Now, there are two types of models we use to understand voltage sources: the ideal voltage source and the practical voltage source. First, let us look at the ideal voltage source. As shown in the diagram on the left, the ideal voltage source is assumed to have zero internal resistance. That means, inside the source, there is no opposition to the flow of current. As a result, the entire voltage appears at the terminals, and there is no drop or loss. So if the source is rated to supply a voltage V, then the terminal voltage is exactly V, no matter how much current is drawn by the load connected to it. This is why, in the graph below the ideal voltage source, you see a straight horizontal line. It shows that the terminal voltage remains constant even when the current increases. This is a perfect situation, but it only exists in theory. Now, let's move on to the practical voltage source, which is shown in the diagram on the right. In reality, all voltage sources, whether they are batteries, generators, or power supplies, have some internal resistance, even if it is very small. This internal resistance is shown in the diagram as Rs. Because of this resistance, when current flows through the circuit, some voltage gets used up or dropped inside the source itself. This means that the voltage available at the terminals, which we call terminal voltage or VT, becomes slightly less than the actual voltage V of the source. The more current you draw from the source, the greater the voltage drop inside due to the internal resistance, and the lower the terminal voltage becomes. This behavior is shown in the graph below the practical voltage source, where the red line slopes downward. This slope shows that as the current increases, the terminal voltage gradually decreases. So in summary, an ideal voltage source keeps the terminal voltage perfectly constant, regardless of the load or current, and has zero internal resistance. On the other hand, a practical voltage source has some internal resistance, and its terminal voltage drops slightly as the current drawn from it increases. This small drop in voltage is important to consider in real-world circuit design. Understanding the difference between these two models helps us predict how a power source will behave when connected to different electrical loads.